You can choose any of the pump as a controlling pump. And if your company says you need to change this to every month, you can keep on changing it. Just click over here. Sorry. Just click on this. This will show you a button here. Select as controlling pump. So click on this. So this will turn into controlling. So these two become column. The controlling pump actually respond very quick to the load change, which means now let us say your engine is running at 50%. Suddenly, captain reduce the load to just slow ahead. So if we have this kind of an arrangement, there will be a lot of oil. The set point will also come down. So all these pumps have to reduce the start rate. So what happens is the controlling pump start rate immediately come down, maybe 20%, 30%, maybe 10%, to a very high percentage. Then these two pumps will slowly adjust, okay, to maintain the set point. Once the set point is adjusted, then the controlling pump will slowly increase again to 50%. So at that time, these two will come down. So controlling pump always comes to 50% and remain there all the time once the load is stabilized. Controlling pump comes back to 50% once the load is stabilized so that it can quickly respond to either direction. That is the reason. So let us say we are moving to 100% MCRR load. So suddenly controlling pump will go boom, 100%, then slowly these guys will fall. Then when they reach around 70, maybe this will slowly come down to 2. That is the mechanism of the controlling. Is it clear about the mechanism of controlling pump and the follow pump? And you can also change this pump monthly if the company says every month change over, you can do it. Otherwise, one pump will have more running hours, other will have less. Now another, let's slowly build it up. This pump failed. What happened to this? ACU1 damaged. We don't have a spare ACU from an NPC, and we are not time to change it. We are manual. Pilot is on board. What happened to this pump? When you're running ahead, it gives you 100% oil. When it runs astern, what happens to the pump? What does it do? Does it supply or does it not supply? And what will happen to it in the running condition when the engine turns the direction to astern? We already discussed in the first session. If this remains 100% ahead and the captain gives astern movement, these two will turn to other direction, minus minus. This will still remain like this. So what will happen to the suction discharge of this pump? The suction discharge will interchange, which means this will be a suction, this will be a. But if you see here, there is an on-and valve here. You cannot suck anything more. Whatever is in the pipe only can suck. So there is a very good chance the pump can go run. So then what happens? There is a check valve here. Through this check valve, and keep the pump running without having a dry run situation. Same for this, same for this. Any questions here? Very important part. Nothing? Very nice. Now I'll give one more situation. We are running full speed onto the all good. Electrician was doing Saturday routine. He caused a problem. Your engine room got blacked up. No power supply. The blackout situation. Engine was running at 100 RPM. Now, what is the condition of this fans? Are they running or are they stopped? Why everybody is silent?
There's nothing in the chat, Francis. Everyone's very quiet.
I know. I was wondering whether I'm only talking to you.
Can you hear me, sir? Hello?
I think so.
Okay, you are there, huh? Very nice. That is good. Okay.
So can you hear me, sir?
Yes, I can hear. I can hear a lot of noise.
Yes.
Now tell me, what will happen to the pump? Will they run or will they will stop immediately?
The main engine will stop, sir. Main engine will stop. The pumps should also stop.
Immediately. That is my question. The moment the blackout has happened, like a brake, tuck, main engine stop. Will that happen? Will not happen, no?
It will not happen immediately, sir. It will take time.
It will take time. It is running still at maybe 40 RPM, 60 RPM, come down slowly. So similarly, the pumps also will run like the same way. What is the pressure here? I want to know what is the pressure here now.
Suction, no? The main lube oil pump will stop, sir. So the pressure will be down, sir. If it's a suction side.
Yes, it is suction side. So it will be zero pressure here, okay?
Yes.
Zero. But pumps are running. So the bottom line here is, when you go on a ship with the ME engine, there should not be any blackout. Rather, the electrician should not do Saturday routine. That's what. So we need to take care of this part. Anything can happen on the ship, no? Which means we must have oil coming there on the suction side, or we need to stop the pump immediately. Two options we have. In 10 seconds, the pump should stop. That is not possible. The second option is give some oil here on the left side. So how do we get the oil there?
Have some header system, sir? Should have.
No header. Good thinking, but no header. Any more guess? Okay, I'll give you the hint. This valve will open. Okay? This valve will open. Now you tell me, how does that valve open? If you can tell me the answer correctly, you have understood the system at least 7%.
Is that valve possibly automatically opened when this kind of situation occurs?
Good suggestion. Good understanding. How it will automatically open? That is correct. What you said is absolutely right. How does it automatically open? We got a blackout.
So it's a.
So the solenoid will be de-energized?
Solenoid will be de-energized. Yes, solenoid will be always de-energized. Always. Even when engine is running, it has to be de-energized.
Normally open, sir.
That is a nice word, but it doesn't make any sense here. When you say normally open, means this valve should be always open. No, if it is always open, you will not.
When it is energized, it will be closed, sir.